Good morning. My name is Richard Quenneville. I'm the corporate occupational hygienist for T. Harris Environmental Management, Inc. I'm presenting the first of a series of occupational hygiene webinars today. We've got several that are going to be presented today. I will be presenting on infection prevention and control in buildings. We have at 12 noon, if you're dial into the same log on, you can listen to Prevention by Design and Occupational Hygiene Perspective by Don Webb, one of our other industrial hygienists, and he's going to present on the NIOSH prevention through design concepts and how it relates to ventilation or project design and looking at eliminating hazards and risks to workers as early as possible in the cycle of products, equipment, or workplaces. At 2 p.m. this afternoon, one of our junior occupational hygienists, Jordan Cabral, is going to talk about ergonomics at the office and working from home and proper way to set up computer workstation and layout, lighting and equipment setup. And finally this afternoon at 4 p.m., we have another one of our occupational hygienists, Lisa Shawn, is going to present on infection control with respect to COVID-19 and cold and flu season. So I'm going to start off. The intention of my presentation this morning is to present more or less a literature review of controls that can be applied for COVID infection, COVID-19 infection prevention. A little bit about myself. I'm a Queen's University graduate, bachelor's honors in chemistry. I'm a certified industrial hygienist, and I'm a registered occupational hygienist, and I've been so since 1990. I'm past president for the Canadian Registration Board of Occupational Hygiene, and also been past president of the Occupational Hygiene Association of Ontario. Something that I recently took on last year was becoming an OHS learning trainer. I have 22 years of experience in occupational hygiene in manufacturing, specifically in telecommunications and pharmaceutical manufacturing, and I have 17 years of experience as an occupational hygiene consultant. I've dealt with risk assessments, occupational exposure assessment strategies, exposure modeling, statistical analysis of sampling data. I'm a subject expert in asbestos, lead, mold, silica, isocyanates, nanomaterials, welding, heat stress, Legionella, and many other assessment strategies, including dermal exposure assessments, biological exposure monitoring, and occupational exposure banding. So what I want to present, as I said, is some presentations and papers from some reputable occupational hygiene sources and their recommendations for infection prevention and control of coronavirus disease, COVID-19. Specifically, what I'm going to be reviewing are some of the recommendations from the presentation by Workplace Health Without Borders, Dr. Brosseau. Also recommendations from the American Industrial Hygiene Association, the American Society of Heating, Refrigeration, and Air Conditioning Engineers, as well as the American Conference of Governmental Industrial Hygienists. So the initial guidance from World Health Organization on the SARS-2 virus, the main concern was that it was spread mainly from person to person by close contact. And there was recognition of asymptomatic spread of people with no symptoms, but it was primarily thought to be from the respiratory droplets, and inhalation or airborne transmission was initially not considered a concern. So the routes of transmission, according to the World Health Organization, well, essentially contact. You could have transfer from an infectious source to the mucous membranes. That is essentially transferring the virus to your eyes or your nose or mouth and having exposure that way. Secondly, droplet exposure, large droplets that are propelled onto the face or the mucous membranes from, say, somebody sneezing. Essentially, no inhalation involved here, but basically the droplet transfer. Airborne, basically, we're talking about the droplet nuclei that are inhaled only when a person is far away from the infection source, and aerosols, with aerosols being the droplets or particles inhaled near the source. So as previously stated, World Health Organization indicated that contact was perhaps not as important as originally thought. Droplet transmission was important. So the recommendations that we all heard last year, early in the pandemic, about using face shields and distancing. Again, airborne not being very important in the early part of the pandemic, but certainly that opinion has changed, and it is definitely more of a prominent source now. So the air we breathe, aerosolization can occur through breathing, singing, shouting, coughing, sneezing, and even the viral shedding in the human feces. If you flush the toilet, you can have aerosolization occur. So perhaps it's useful here to provide a definition of what an aerosol is. So in occupational hygiene terms, an aerosol, as used here, is a suspension of tiny particles or droplets in the air, such as dusts, mists, or fumes. These particles may be inhaled or absorbed by the skin and can cause adverse effects for workers. So medical procedures, a big deal in healthcare. Certainly some of the intubation procedures generating aerosol from the humans. Of course, aerosolized materials can be deposited on surfaces and certainly be suspended in the air by human activities. And the closer the quarters, the more likelihood to have accumulation. And the thinking being that transmission is not necessarily from a single hit event, but from cumulative inhalation exposure. And the concerns being that, you know, ventilation disperses aerosols, so that's an issue. So Dr. Brosseau presented to the World Workplace Health Without Borders community early last year. One of her first presentations that I came across, supporting airborne transmission of aerosol particles as being important. So in the slides here, you see that speaking and coughing can provide a wide range of particle sizes, ranging from less than 1 micron or ultrafine particles to greater than 5 microns inside or the inhalable range. So the top chart A shows the range of particle size, and on the x-axis and the y-axis the concentration. You see certainly similar distributions for speaking and coughing. And not to be surprised, coughing produces higher concentrations than speaking. So if you look at the American Conference of Governmental Industrial Hygienists definition of particle size selection fractions, respirable particles are between 0 to 10 microns, 50% cutoff being at 4 microns. So these are, by this definition, these are materials that are hazardous when deposited in the gas exchange region of the respiratory system. So we see certainly we have particles in that size in both the chart A and B for in the 1 to 2 micron range. So what's the significance of that? Well, the small particles take a long time to settle in still air. So the chart on the right shows, for example, a particle size of 0.3 microns would take up to 2.8 days to fall 1 meter in still air. Whereas a particle size around the 3 microns takes 1 hour to fall 1 meter in still air. So we're in the 1 to 2 micron particle size for speaking and shouting and singing. So we know that it's going to be suspended in air for a long period of time. The chart on the left shows the concentration of particles per second generated from quiet, so that's just say breathing, intermediate, which would be maybe normal talking, or loud, up to 0.8 particles per second. We could associate that maybe with loud talking or singing. So the louder you speak, or the more forceful the exhalation, the higher the particle count generated, and the fact that it stays suspended in air for a long period of time. So this chart shows essentially small droplet inhalation aerosol dominates most at distances during talking and coughing. Your large droplets are only going to be important when you're within 0.5 feet or 1.5 feet for talking or coughing, and this chart shows that distance. So that's I guess the reason for the recommendation for the 2 meter distance to prevent exposure to the large droplets. Dr. Brousseau presented in her presentation, she talked about the traditional occupational hygiene measures of control. You know, you can control the source of your contaminant. You can control the pathway from the source to the receptor, or you can provide your controls at the receptor. And certainly the effectiveness decreases as you move from source to pathway to receptor. And the traditional recommendations. So for source control, you can eliminate the exposure. You can screen for symptoms and other risk factors and eliminate the generation of the COVID-19 virus particles. You can test for infection and screen, exclude and quarantine, or have people work from home if they're positive. Substitution, you can look at job design, redesign, isolation. Removing the source, lowering the concentration, well, increasing the distance, decreasing the number of people, shorter shifts, or job redesign, working from home so you're not exposed. And Dr. Brousseau's recommendations, pathway controls for hazardous aerosols. How do you control the pathways? Well, you can use dilution ventilation. You can use local exhaust ventilation, so like portable air cleaners. You can introduce barriers, but there's issues with the use of barriers because you can effectively change airflow patterns and dilution. You could actually result in high particle concentrations. You could exacerbate or create other issues and may have unwanted effects, unexpected effects on particle movement. Another paper I reviewed was a document put out by the American Industrial Hygiene Association. and titled Reducing the Risk of COVID-19 Using Engineering Controls in August of last year. And this chart basically shows the traditional hierarchy of controls, another way of showing the hierarchy of controls from most effective to least effective. So at the top of the inverted pyramid, elimination of the source being most effective, substitution, engineering controls, and administrative controls, basically procedures, staggered schedules, and at the very bottom, the least effective being the personal protective equipment. So, primary means of disease transmission is indoor spread of the exhaled droplet aerosols. So there may be an incorrect assumption by employers and the public that face coverings or respirators are the only way to reduce risk of exposure. And this chart shows some of the more effective controls that are not personal protective equipment. Maintaining social distance and PPE or using personal protective equipment is low on the hierarchy of controls. Engineering controls are more reliable and less prone to human error. Other issues with PPE, the cost of personal protective equipment may be higher than most employers realize. If you're going to be providing actual respirators, you're looking at required under CSA standards and OREG 833, you're looking at required medical evaluation for fitness to wear a respirator. You need to do fit testing to make sure you're getting a good fit for the respirator assigned, and training. And so PP probably is best for short-term solutions until engineering controls can be applied. So AIHA does recommend some other broad engineering controls. So they do talk, their paper did talk about physical barriers, enclosures and guarding, maybe the implementation of automatic door openers and sensors, local exhaust ventilation, enhanced filtration to capture infectious aerosols or devices that kill infectious organisms. Increasing your dilution ventilation and increasing outside air delivery, and maintaining your relative humidity within specified levels. Following chart explains how dilution ventilation can affect aerosol exposure to hazardous aerosols. So by increasing the number of effective air changes per hour in a room using your dilution ventilation, you're essentially increasing the amount of clean or outdoor air delivered to the room. And you're effectively lowering the occupant level of exposure to airborne viruses and thereby reducing risk of contracting the disease. So the minimum level of protection offered should exceed the protection offered by personal protective equipment alone. So an N95 respirator offers about a 90% relative risk of reduction. Therefore, if you look at this chart here, you actually need to be at least 6 air changes per hour or better to exceed the protection provided by PPE. You can enhance your dilution ventilation with some practical and immediate solutions. You can introduce standalone off-the-shelf HEPA filtered air cleaners, and they will increase your effective air changes per hour, substantially decreasing the likelihood of inhaling an infectious dose. You can enhance the filtration in your central HVAC system for your dilution ventilation, and you can increase the volume of outside air or your fresh air. You can also look at enhanced filtration and outside air according to them. HEPA-rated filters may not be absolutely necessary in your HVAC system. You can enhance your filtration using filters that are rated as MERV 13 to 15 to reduce infectious aerosol concentrations in recycled air. Now, there is some requirements. If you do increase your MERV ratings of your filters, you may require higher flow rates. You're going to have to look at your HVAC system to ensure that your fans can handle the increased pressure load, and it's going to result in more maintenance and filter changes because you're pushing more air through your system. And you got to worry about having too much outside air causing high relative humidity levels in the summer or low relative humidity levels in winter. And be aware that outdoor activities may require you to shut your dampers if you've got lots of construction or excavation or demolition that is introducing contaminants into your fresh air stream. So one of the things that's actually important control is the role of relative humidity in your HVAC system. I presented some of my earlier slides. I pointed out the fact that the smaller the particles are, or the aerosol particles are, the longer they stay suspended in air. And they can basically float, particles in the 1 to 2 microns can stay suspended for a long period of time. So if you have large droplets being, aerosol droplets being generated, if the relative humidity is low, the droplets can shrink down to nuclei size and thereby remain airborne much longer. Pathogen infectivity is high when relative humidity is less than 40%. If you've got low relative humidity, you've got the smaller particles, they stay suspended longer, greater aerosol transmission, evasion from surface cleaning through resuspension of these very small particles. So these infectious droplets, they'll float in air longer and travel further. When you control your relative humidity within between 40 and 60%, your infectious droplets will settle out of the air quicker due to the larger size. And the chart on the right shows a plot of influenza A virus infectiousness relative to relative humidity, and you see much higher levels of infectivity below 40%, and it drops when you have the control at 40 to 60. So really, I think this shows that you need to balance. You need to control your relative humidity, but you're also having to balance the amount of outside air depending on summer or winter conditions. So I also looked at the ASHRAE position on filtration and air cleaning, and basically I'm going to talk about a few points. This was approved in 2015 and reaffirmed in 2018. And so some of the positions from the American Society of Heating, Refrigeration, and Air Conditioning Engineers that, they also conclude that mechanical filters are shown to significantly reduce indoor particles, and as long as you're using MERV 13 to 15. They also looked at electronic filters and concluded that they were, depending on the manufacturers, they range from relatively ineffective to very effective at removing airborne particles, and therefore providing either no benefit to some benefit. So the diagram on the left essentially shows your dirty air entering into an electronic filter. There's a pre-filter to pull out the large particles. You've got charged plates creating electrical charge and ionizing the particles. They stick to the plates. You have an after filter and what essentially have clean air coming out the other end. Again, ASHRAE position is that some are effective, some are not, and really you need to scrutinize the manufacturer's spec and the equipment. And ASHRAE also concluding you want to keep your relative humidity between 40 and 60%. They also looked at photocatalytic oxidation technology and concluded that it was shown to remove contaminants and to be, depending on the manufacturer, either ineffective and or generate harmful contaminants such as ozone. The diagram on the right essentially shows how the technology works. You have an ultraviolet light source irradiating a titanium dioxide photocatalyst, which generates hydroxyl radicals. The hydroxyl radicals interact with the virus particles and destroy the cells. So ASHRAE position, it can be ineffective depending on the manufacturer, and some of the manufacturers can generate ozone. So their position is that you should be staying away from devices that generate ozone in an occupied space. ASHRAE supports the use of ultraviolet systems to inactivate viruses, bacteria, and fungi, and it's been shown to be effective. And here on the photograph on the right shows UV lamps placed inside the HVAC system, and essentially as the air passes through the system, it's irradiated and you kill the viruses. The added benefit of UVC, if you're using humidification and you have issues with mold growth on your plates, this will also clean the system and inactivate fungi as well. So I looked at the ACGIH ventilation for industrial settings 2020 paper, and this document was geared towards manufacturing. What can manufacturers or employers with large warehouses or manufacturing space do to control coronavirus? So this white paper offered recommendations and essentially talks about the fact that there are two types of ventilation that can impact concentrations inside the building. You can use general exhaust ventilation, or such as dilution ventilation, or local exhaust ventilation. ACGIH recommends in this case that you perhaps do an audit of your facilities to determine how the air enters and exits the space in order to put the controls in place. So dilution ventilation uses exhaust fans to pull air into the workspace, and you introduce makeup air and supply fans to replace the air that's been removed. If open doors, windows, and vents are the only source of replacement air, you might want to consider the use of ducted power systems, where you introduce your supply air at or near the floor level. So this allows your replacement air to move past the worker up to exhaust fans up in the ceiling, and so the air passes by the worker without moving the contaminants in other workers' breathing space. And this can be combined with social distancing. If there is a supply air system existing in the factory or the warehouse, consider modifications to the ducts to deliver air at or near floor level, as per figure 1, to avoid the air passing from one worker to another. So this form of displacement ventilation or dilution ventilation takes advantage of the warmer air at the breathing zone rising upwards towards the exhaust. As per figure 2, you have warm, moist, light air being expelled by the human lungs, and because of this warmth and body warmth, it's lighter, it rises to the ceiling. You create an induced air thermal plume. If you're going to use a displacement ventilation system, you want to ensure that you're introducing the air at low velocity for high toxicity contaminants such as this. You want to prevent turbulent air mixing. So ACGIH talks about local exhaust ventilation as well. Figure 3 on the right shows a typical local exhaust ventilation system. It comprises of some kind of hood, ducting to an air cleaner. You have a fan that's drawing the air through the ducting, and it's just discharged outside of the building. So your local exhaust ventilation systems, they're using a dedicated fan and duct to capture the contaminant at the source. The advantage of an LEV is that you can lower the airflows and volumes of makeup air required. The disadvantage is that you have a fixed capture point, not always located at a point of contaminant generation, the worker face. Infected workers are mobile sources, so a fixed system may not be necessarily practical. Perhaps a mobile HEPA filtered system to recirculate the air is a possibility. In your factory or your manufacturing space, you may have large ceiling fans creating downward airflow around the workers, and this can potentially return the buoyant viral particles back into the worker breathing zone. You may want to consider taking these downward fans offline. Look at replacing, ensuring that air is replaced at or near the floor with a roof exhaust to promote displacement ventilation and ensure an optimum direction of airflow from floor to ceiling. Now, depending on the type of manufacturing you're conducting, you may actually have hot processes in your factory, and personal cooling fans may be necessary to cool for heat stress prevention. Now, they should not be removed, but what you can do is ensure that your airflow is from a clean area to the affected area, and you're not blowing air from one worker to another. So ACGIH also provides recommendations on filtration. You want to have 99+% of particles, sorry, if you want 99+% of particles filtered, you need a HEPA MERV 17 or greater. Existing systems may not be capable accommodating MERV 17 HEPA filter. There are electrostatic charge filters, the Electret MERV 13 or 14. They are capable of providing up from 89 to 97% efficiency on viral particles in filter sizes similar to your existing MERV 5 or 8 filters. So that's an option. The the conventional seasoned fabric filter baghouse systems that in a factory typically exhibit similar efficiencies to HEPA filters, and they can be used to reduce coronavirus distribution, provided the air being reintroduced in the plant is in a non-turbulent fashion and in the preferred directions. Again, the portable HEPA filtration units placed in close proximity to fixed workers may help in increasing the effective air changes rates in the space. So ACGIH talks about the use of ultraviolet germicidal irradiation. These systems are very commonly used in hospitals and homeless shelters. The UV light is very effective for disinfecting fungi, bacteria, and the coronavirus. The systems can be used in ducts, filter banks, or point of use, and they even have upper air room systems. Now, the upper air germicidal units are not currently approved for use in Canada. So you do require controls to protect worker exposure to the 250 nanometer UV source when it's installed inside a HVAC system. So you need lockout systems to de-energize if you have worker accessing HVAC to replace filters or do maintenance. The nice thing about UV systems, they do ensure clean air is returned to the workspace and reduce your need for 100% outside fresh air. So general recommendations for from ACGIH. LEV systems should not be turned off during a pandemic. So if you have local exhaust ventilation systems for other contaminants generated in manufacturing, you should continue to use your LEV systems because they are going to supplement the air change rates in your factory. You want to allow the general exhaust ventilation or dilution ventilation and your local exhaust ventilations to operate continuously, or if you do shut down long enough after the shift change to allow several air changes following departure and before shifts start to ensure you've got sufficient air changes before work begins. So recommendation, permit your LEVs to operate continuously. If you've got fume hoods, you might want to leave your hood sash in the up position to allow maximum airflow for variable air volume fume hoods. Your washroom fans should be left operating continuously at exhausted outdoors. And you might want to look at replacing your air dryers with paper towels during the pandemic to prevent re-aerosolization of viral particles that might be present in the restrooms on work surfaces. So the conclusions. You want to look at increasing outdoor air to 100% or maximum allowed by your HVAC systems. You want to try to increase your air changes to per hour to 6 to 12. which corresponds to 95 to 99.9% purge. You want to look at increasing your filter efficiency as high as your filter racks and fan pressure drop will allow. That'll reduce the particle count in the workspace. If you might want to look at, again, your dilution ventilation at low velocity at floor level with your directed flow from the floor to exhaust fans in the ceiling and spread out over a large area. Allow your general ventilation or your dilution ventilation to operate continuously. Allow all LEV systems to operate continuously. You want general considerations. You want your airflow from cleaner air to less cleaner air and workers on the clean side. And more outdoor air is better. So let's see, I want to allow people to going to turn on the how do I turn on all the people? Let's see. I want to unmute everybody here. I'm just having issues here setting this up. Just a moment. Oh my goodness. Looking how to unmute everybody here. Ask all to unmute. Okay, so at this point, I'd like to open the floor up to questions and any questions on the presentation?
Yeah, hi there. Just wondering if I'd be able to get a copy of the PowerPoint from this.
Certainly, Blake, I should be able to. We're recording the presentation, so we'll make the presentation available to anybody that would like a copy.
Excellent, thank you.
Anyone else? Any questions on engineering controls? Everybody's good. Okay, so the next, if there are no questions, somebody asked, will I be able to get a copy of the PowerPoint presentation? Yeah, I think we can make the video available. We can make the PowerPoint presentation available as well. Anyone else?
Oh, hi. Yeah, my name is Jiping. Very nice talk. Just wondering, do you have any insights or recommendations for residential settings?
I beg your pardon, the conditions for?
Residential settings like homes.
Residential settings. Well, residential settings, well, certainly if you can, if you have exhaust fans in the washrooms or in your kitchen exhausts, you can look at running these systems to increase the fresher introduction into the space. You can look at your go to the. I think you can look at the MERV rating for your furnace filters and certainly look at getting a higher rating, MERV rating for your filtration for your furnace from the from the hardware stores, and you can look at introducing humidification in your homes, specifically in the wintertime. There are portable units that you can buy from the hardware stores, or you can look at putting an add-on to your furnace to introduce more moisture in your furnace system to increase relative humidity. Did that satisfy your question? All right. Any other questions from the audience? Now, the other thing you can do is you can also chat if you're having any issues with your microphone. Okay. I think, therefore, I'm going to thank everybody for your attendance. The next presentation, if you're looking to sit in on the sessions, is going to be at 12 noon. Thank you, everyone. Oh, got a chat. Hang on. Your mic doesn't unmute, so how do I unmute everybody? Let me see. Oh,
I think I got it. Thank you.
Did that work? I think I managed to. I asked everyone to unmute. I think you can click the unmute. And
Yeah, I think I'm. Can you hear me?
yes.
Yes. I'm sorry, I was late. I couldn't get into the webinar, so I might have missed some information. Probably that might covering my question. Just generally speaking, are we looking? Is there a timeline we're looking at, like ASHRAE modifications and specific requirements that we're going to start seeing now for mechanical designs now going into upcoming construction over the next year, or is this like mostly really just recommendations still?
Well, yeah, these are recommendations from the experts on how to enhance your control measures for COVID-19 virus, or manage the rates of infection by engineering control. So certainly these are considerations you might want to look at if going forward, or even something you might want to implement in your existing buildings or facilities.
Yes, it would be great to get a link to the presentation. It would be very helpful. And it's just a question with regards to what working with City of Ottawa and different buildings. We have building automation systems that are looking, trying to make things energy efficient, scheduling ventilations, motor controls, things like that. So that's sort of perhaps working against, pumping ventilation into spaces to keep the air flowing. So that's why I was just asking the question, if there's if anyone's sort of working and researching, and if anything's going to go forward.
Yeah, I think you gotta, if you're looking at COVID-19 or the viral SARS-2 virus controls, you maybe have to set aside your energy conservation in terms of providing more ventilation to control the aerosols. I mean, once we're past this pandemic, I think we can go back to our energy efficient systems, but I think you need to look at the recommendations that are provided here. You want to increase your dilutions, you want to increase your filtration, you want to increase your fresh air, but not at the cost of lowering your relative humidity. So relative humidity control is important, just as important as some of the other things.
Okay, thank you very much.
Okay. Any Anyone else with questions? And you asked about I'm going to be sending the link to this video, and we'll make the PowerPoint presentation available as well. Anyone else? Well, if that's everything, then I want to, let's see. Anything else? I don't see any other comments. Well, I want to thank everyone for attending. This is great. You have my contact information. If you want to reach me offline, I'm available as well. Thank you, everyone. I'm going to turn off the recording. Let's see. Stop recording.